Non-proportional relationships. So when we look at these two graphs, one of them is proportional and one is not. Does anybody know which one is which?
A is proportional and B is non-proportional.
And how do you know that?
Because
A is proportional because it's going through the origin, or it starts at the origin.
Very good. Okay. The origin right here is 0, 0. So when we're looking at graphs, we want to ask ourselves, is it proportional or not? Okay. So once we have a graph, we want to know what's the y-intercept. Okay. If it touches right here at the origin, that is at 0. So the y-intercept is 0. Okay. Over here on this graph, that is non-proportional. It does not touch at 0. We still want to know the y-intercept. What is the y-intercept? 20. Okay. It's going to be super important that you understand how to find the y-intercept. Okay. Even so, more so next year than this year. But that y-intercept is where it crosses the y-axis. Okay. Now, we also know how to find the rate of change, the ROC. Does anybody remember how to find the ROC on a graph?
I think
So on a table, we find the ROC by looking at the outside numbers. But on a graph, we find the ROC by doing rise over run. Okay, this is how we find the ROC in a graph. Rise over run. So we make our little triangles. Now, do I know exactly where it touches on one here, or is it in between? It's in between, so we can't pick that point. Okay, look at 2. Do you know where it touches on 2?
Yeah.
Yeah, okay. So I can make my triangle. Okay. Now that I have my triangle, I count the rise over the run. Okay. Remember to go back and look at your axis to see what you're counting by. What is my y-axis counting by? 1s, 2s, 5s, 10s? 10s. So how far did I rise up? 10. So my rise is 10. Now how far did I run over? 2. Okay. What does 10 over 2 equal? 5. And then every single time we have a rate, what do we want to attach to the end? An x. Okay. Every single time we want to attach that x. So my equation is y equals 5x. And then I can add the plus 0 if I want, but do I really need to add that?
No.
No, okay? But writing it might help you remember, oh, the y-intercept is 0, but you don't really need to write it, okay? Let's come over here and look at graph B. Okay, I still want to find my ROC, my rise over my run. Still need to make a triangle. Do I know where it touches on 1? No. Do I know where it touches at 2? Yes. Okay, so color your little circle in, your triangle, sorry, circle. All right, now how far did I rise up? 10. How far did I run over?
2.
2. What is 10 over 2?
5.
And what do we always attach to our rate? An x. So this equation is y equals 5x plus what?
Okay. Plus
20.
Plus 20. Good. Plus 20. Okay. This one was plus 0 because the y-intercept is 0. Remember, you always want to go back and put that y-intercept in as your plus or minus. That's the b in that equation, y equals mx plus b. Okay? So what do these graphs have in common?
They both kind of like 10 and they both equal 5x.
Okay? So the ROC is 5x on both of them. Okay? They also both make a what?
Linear.
They're linear. Okay, they make a line, so they're linear. Okay? If it has a rate of change, it is linear. If it has a rate of change, it's linear. If you were here in class, I'd make you tell your neighbor. I'd make you tell me. If it has a rate of change, it's linear. Okay? And these both have a rate of change of 5, and they're both linear. Okay, how are they different? Very good. The y-intercept is different. Okay, one is proportional because it touches the origin. Oops, sorry. One is proportional because it touches the origin. The other one is non-proportional because it does not touch the origin. Okay, pretty easy. You just have to have that memorized. Okay, go ahead and turn to the next page. Yeah, we're skipping some of this stuff because it's not really important for 7th grade. Okay, non-proportional is when you have a constant rate of change. Okay, constant again just means the same. Okay. A graph will not pass through the what? Origin. Okay. If it does not pass through the origin, it is non-proportional. If it's non-proportional, it does not pass through the origin. Okay. Instead, it's going to cross at a point called the y-intercept. And non-proportional relationships are still going to be linear. They're still going to make a line because they have a rate. Okay. Linear rate. Rate, rock, think of rocks. You throw rocks in a straight line. Okay. One way to tell in a verbal or an equation is that something is added or subtracted. Something is being added or subtracted. So for example, y equals 7 minus 2x, or y equals 3x plus 9, okay? Something is being added or subtracted. So basically, if it has one of those plain numbers, a constant, it's non-proportional. Okay, if it only has a rate, it is proportional. Okay, something's added or subtracted, it's non-proportional. Okay. All right, let's look at a word problem. In her search for a gym, Hillary found a location that charges $10 as a one-time fee and $20 each month. Okay, so if I'm going to pay for that first month, I have to pay the $10 fee, but I also have to pay $20 for each month. Well, how many months is that first month? Just one, right? Okay, so 20 times 1 is, plus 10 is 30. So for that first month, I'm paying $30. Okay, for the next month, now I'm $20 times 2, because it's 2 months, plus 10. How much am I paying now?
50.
50. How much do you think I'm paying for 3 months?
70.
70. 4 months?
90.
90. Okay, now this is where it gets a little weird because people think if it's 0 months, I'm not paying anything, but I still have to pay that $10 fee even though I haven't done anything yet. So that first month is still $10. Okay. All right. So, reminder on a table to find the rock. You look outside. Rocks. We add and subtract rocks. Rocks are thrown outside. Okay. 50 to 70 plus 20. 70 to 90 plus 20. Okay. Your life is good when all the numbers are the same. Okay. That doesn't necessarily mean you're done. You need to check the other side just in case. 1, 1, 1, 1. Okay? So the rate of change, remember rock, is 20 over 1, which equals 20. And what do we always attach to our rate? An x. Okay? Now, looking at this table, does anybody know what the y-intercept is? Remember I said the y-intercept is when x is 0. So when x is 0, what is y?
10.
10, okay? So the y-intercept is 10. Okay. If we were to graph this, my first point would be 0, 10, 1, 30. Now I'm just going to stop right here because what's the y-intercept? 10, okay? So on a graph, it's where it touches the y-axis. On a table, it's when x equals 0. In a word problem, it's going to be whatever is added. So there's a $10 fee. Okay? So if we were going to write our equation, we always start with y equals. What was our rate? What did we say our rate was?
Y equals 10. I mean 20. Times
20x. Okay? Remember your rate is y over x. Your rate could also be found by doing this. Okay? Your rate could be found by doing this. The rise over the run. Now watch here. Your rate is also the thing when you see the word each, every, per, that tells you you have a rate. Okay? And we'll look at some in just a minute. Now, what was my y-intercept? 10, 10, 10. My y-intercept is plus 10. If it doesn't say negative or if you're not subtracting, then just know that you're adding. Okay? All right, turn to the next page. It says Jackson currently has $35 in his bank account, so I know that's what he has. He is saving $15 a week. If you are saving money, are you putting it in your account or are you taking it out? Putting it in, which means plus. Okay? And I'm doing that every week. So which one of these things do you think is my rate? What's going to happen every single time? The 15. So the 15 gets the x. Okay? Now here you can notice they switched it. That's fine. Remember, adding the order doesn't matter. As long as 15 and x go together. I know that x goes with 15 because it says each week. Okay? If you see the word each, every, per, monthly, daily, that's going to tell you that's your rate. Okay? All right. Down here at the bottom. When you're given an equation, what, Carlos?
Did I unmute?
Yeah. Okay, so down here, these are the equations. What number is my rate of change in this equation?
I think it is.
Is it the 0.5 or the 9? And how do you know it's the 0.5?
Because it has the X.
Yes. If you didn't know this, your rock has your x attached. Your rate always, 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 always has the x. Okay? So what's the y-intercept?
9.
9. So is this a proportional relationship?
Wait.
So we just wrote in our notes, non-proportional means something is added or subtracted. Okay? Is this proportional?
Yes. It's added.
So non-proportional
No,
means something is added.
It's non.
It is non-proportional because it has plus 9. Okay? On the next one, what is the rate?
2.
What kind of 2?
-2.
Okay, the sign is important. Make sure you take the sign with it. Okay? What's the y-intercept?
8.
What kind of 8?
Negative.
Negative 8. Okay? Is this proportional?
No.
No. Why not?
Because it's not subtracting.
Yep, we have a -8. We have something subtracted. We have a plain number. Okay, on number 6, what's the y-intercept? Sorry, what's the rate of change?
15.
15. What's the y-intercept?
0.
0. Is this proportional?
Yes.
Yes. Okay. Super, super easy, right?
Yeah.
Okay. X, rate of change. Plain number, y-intercept. Okay. We're actually going to go backwards to page 33 real quick because I want to look at some word problems. Okay, so go backwards to page 33 real quick. All right, it says a restaurant charges $10 for a pizza and $1 for each topping. Is this proportional? Remember, I said proportional means something is added, or non-proportional means something's added or subtracted.
It's non-proportional.
It is non. Okay, so our equation would be y equals. Which one of those is something that's happening every time, or each time, or per?
$1 for each topping.
1. Okay, so 1x and $10. Okay. Now, technically, you don't put the x, the 1, you just put x because it's understood. Okay. You could say I have $1 or you could say I have $1, but you don't really need the 1. They're the same thing. Okay. The next one, a restaurant has all-you-can-eat buffet. It's $8.75 per person. Is this proportional?
Yeah. No. Yes, it is.
Yes.
It's not adding or subtracting.
What is my equation?
They charge.
It says $8.75 per. What does per tell you?
Per one.
Per means it's going to be your rate. It's your X. Okay? Each, every, per, monthly, daily, those things tell you that put an X there. Okay?
So you put the X in
Next
there.
one. A restaurant charges $3 for a cup. Refills are complimentary. That means free. Is this proportional? Is anything else being added or subtracted other than that $3?
No.
Okay, so
No.
if nothing's being added, what do we do?
It's non.
It's non-proportional. Yep. Okay, my equation is y equals 3x. All right, last one. A restaurant has build your own salad. It's $3.80 per pound. Is it proportional?
No.
Yes.
Proportional?
No. Something.
Oh, proportional means something is being added or subtracted. This one is proportional. Sorry, I didn't catch that. Proportional means nothing is added or subtracted. So is it proportional? Yes. What is my equation?
Y equals
380
X.
x. Again, every time I see that word per, each, every, I'm thinking attach an x to it. Attach an x to it. Attach an x to it. Okay? All right. Now we can go to the next page. Page 37. It says a baby giraffe measures 6 feet tall when it is born. It grows a half a foot each month. Okay? 37.
Oh.
So let's write our equation. Y equals, okay? What is happening every single time? What's being repeated over and over? The 6 or the 1/2?
1/2.
And how do you know
One
that?
half.
Because it says the baby's foot is going each month. 1/2 foot each month.
Each. Okay, so it's 1/2. I had 2 people who knew that, apparently. 1/2 is each. And when I see each, every per, what do I attach? An X. Okay? And then it's already 6 foot tall. So am I going to add 6 feet or subtract? If you're growing, what's happening?
Adding.
You're adding. Okay? So is this proportional?
Yeah. No.
No.
You're adding.
No, because something is being added. Okay? if we were going to fill this chart out, when this elephant comes out of its mama, it's already 6 foot tall, so 0 is 6. Okay? At month 1, it grew a half an inch. So what is it now? 6.5. Month 2, what do you think? 7. 7.5. 8. 8.5. Okay? If I was going to ask you if this was proportional just based on this graph, what would you tell me? Sorry, on this table, what would you tell me? Non-proportional. Why not?
Because you're not adding and subtracting.
There's not 0, 0. Okay? It's 0, 6. So it's not proportional. Okay? And 6 is my y-intercept. And 6 is my plane number. And where do you think my graph's going to start?
6.
Starts right here at 6. Okay? Super, super important to know those things. Okay? Your plane number is your y-intercept. It's when x is 0, and it's when it crosses the y-axis. Okay? Turn the page. All right, now we're going to think backwards a little bit. Okay? First of all, is this proportional or not?
It's not.
It is non-proportional. Does anyone other than Gavin and Zanaya know the answers? Because they're the only two I hear. It is non-proportional because something is being what? Added. Okay? 1.5 is the rate. Okay? So look down here at your x. Your x is talking about what? Number of toppings. So what do you think the 1.5 means? If we're talking about the cost of a pizza. Yes, good, Zanaya. It's $1.50 per topping, or for each topping, or for every topping. Okay? You don't just pay for the topping, though. You also have to pay for the pizza. How much is the pizza plain? $12. Good. So you're paying $1.50 for a pizza, and then you're paying $12. Sorry, $1.50 for the topping, $12 for the pizza. Everybody okay with that? Okay, as a reminder on the bottom, if you just have a table, how can you find the rock? Where do we find rocks? Outside. So we're looking at those outside numbers. From 6 to 12 is 12 to 18, 18 to 24, 24 to 30. Okay, over here on the other side. Plus 5, plus 5, 5, plus 5. So my rock is 6 over 5, which equals what?
30. No,
1 point.
5.
1.75.
Use y'all's calculators. Six divided by 5, guys.
1.2.
1.2. So my equation would be y equals 1.2x. Okay? All right, go ahead and turn to that last page. All right, this time we just have a graph. Okay, what's the y-intercept?
20.
20. Everybody, what's the y-intercept?
20.
Okay, so that means
20.
when x is 0, y is 20. Okay? In my graph, my equation, I'm going to add 20. Okay? So this number comes from this number, comes from this number. You need to know they're all in the same place. Okay? It's where it's the y-axis. It's when x is 0, and it's the plus or minus here. Okay? Now I need to find the rate. How can I find the rate?
You don't do.
Plus 9.
We got to do our
Oh.
triangle, right?
Yeah.
Okay. Now you can do the one down here, but I wanted to give myself more space. Okay. Remember, make sure you pick the dots that are on the line, not kind of in the middle, because you can't guess. Okay. So here, I notice that I'm counting by what? From 80 to 100, we're counting by 20s. So this is 20, 40, 60. So my rise is 60. And then the bottom, I'm counting by ones. How far am I running? 2. So what's the rate?
60, 30.
And what always gets attached?
And then this.
An X. So then that comes up here in the equation. And then we just stick a Y equals in front. Okay? Everybody okay with that?
Yes.
Make sense? Okay? Some of it you're just going to have to remember and go back and look at your notes. But for the most part, we're just going to practice now to make sure that you know what you're doing.